Hi, Econ 112. I hope you all are ready for another fantastic adventure into economics. So remember in chapter 10, we started talking about organizing a lot of production. So what do we do when we're a firm? What decisions do we make? How do we start to determine how much? What am I producing? How am I going to produce it? What am I going to do? You know, those basic initial firm questions. Now, the third section of this course is all about firms. So now we're going to transition into chapter 11, where we're going to start to talk about outputs and cost. How much am I producing? At what cost am I producing it at? How much cost is it going to cost me to produce one more of something? How much product can I have if I add one more of something? If I add one more worker, if I add one more machine, how is that going to affect our output? So we're going to be looking at the output and cost decisions of firms today, which is actually pretty interesting, I think. So let me go ahead and share screen, put this down there, do this, do. Okay, I'm not getting very fast, but I'm at least getting somewhat faster than I was when I first started online teaching. So what are the really interesting chapter goals? Before I even get into this, I want to explain something to you. Chapter 11 is very graph heavy. I know that some of you struggle with graphs. If you struggle with graphs and you're not getting the information that you need from the lecture videos, you need to come and talk to me in office hours. I would be very, very happy to help you through any of these graph related problems, but I need to know that you need help, right? So if you come to me, you say you need help, we'll set an appointment. If you can't make it to my office hours, that's okay. We can find other times. I will still work with you, but we're going to need to work through some of these if you have some problems specifically with graphs, because I want you to be successful in this course. So the really important things to get from this chapter, first we're going to learn the differences between short and the long runs, right? What decisions can I make right now? What changes can I make right now? What are my short-term goals versus what changes can I make if I had unlimited time? What things could I do if I have unlimited time? What are my long-term goals? So your short and long-term goals are often not the same thing, and we're going to have to rationalize why they're different. Then we're going to look at two particular types of graphs. We're going to look at short-run product curves and short-run cost curves. How much can we produce when we add in one more worker in the short term? Or how much does it cost to produce one more of something in the short run? Then we're going to look at long run average cost curves. So when we start thinking about the long run, we have more control over what we can do because we have lots of time to make decisions. What does that look like in the big picture? So let's think about these decision timeframes, right? Firms make many decisions, and they do this for one main objective. It's because they want to maximize their profits, right? Now, profits can sometimes be positive, they can sometimes be negative. Don't worry, we're going to talk about that. I know that that seems strange, and maybe in the long run they might be zero, but we really want to be able to make profits. Some decisions are critical to the survival of the firm. Do I build a new location? Do I change my payment system? Do I change the product that I'm producing? There's lots of decisions that can be critical to the survival of a firm, and some decisions are irreversible. If I fire a CEO, or if I completely change my strategy and move to a different state with my firm, these are often irreversible decisions. So we have to think about time frames. What can I do right now, i.e. the short run, versus what can I do after many, many years, i.e. the long run, right? Some decisions that are easily reversed and are less critical to the survival of the firm, but still influence profit, a lot of the time we call these short run decisions. For example, do I send someone home early today? Do I decide to put someone extra on cash registers? Do I decide to prioritize one of the production lines versus a different production line today? Those aren't going to make or break a firm. Those are sort of short run decisions that we make to sort of adjust for what the reality is for us right then. Then we also have long run decisions, the ones that tend to be a little bit more permanent, right? Do I start an entirely new factory? Do I decide that I'm no longer making blue SUVs and I will only make green cars, and I've completely changed all my equipment to do so? The major decisions that might affect the firm. So let's think about this difference between short and long run. With the short run, these are time frames in which the quantity of one or more resources are fixed. Let's think about, we're going to talk about a cookie company because I'm getting tired of talking about pizza. So today we have cookies. Dr. Plemmmons cookie emporium. Okay, so when we have a cookie company, let's assume that I can make some changes today in the short run, right? I have my business. We have our really, really big oven in the back, but we only have one of them. We have our big oven. And then we have 3 or 4 workers who can come in or can't come in, depending on how I call them, right? Well, in the short run, my capital's fixed, right? I only have that one oven. I can't get a brand new oven installed and put in and making cookies today. I cannot change the land component. I can't move my entire business somewhere else today, right? So in the short run, some of these things are fixed. I can't control where we're located. I can't control how much capital I have in the form of this oven. What I can control is maybe the labor resource. I can say, hey, we're really, really slammed today. Let me call in another employee. Or, hey, we're really, really slammed today. Maybe I need you, can you work through your break, and then we're going to give you a longer lunch break later, and then can you work extra tonight? But we can make these sorts of decisions in the short run, which, by the way, I heard something crazy the other day on TikTok, and I'm wondering if this is actually true. So I hold phone like this when I'm pretending to have a phone, because this is similar to like the curved phones that I had when I was a kid. But I hear that apparently kids today do it like this, or Gen Z, Gen Alpha, whatever, tend to hold their phones like this when they're making their fake imaginary phone thing. Which one do you do? I'm kind of interested. Like, am I just antiquating myself to the 1990s when I hold up a phone like this? Anyways, doesn't matter. Okay, so in the short run, something's fixed. We can make some decisions, and these decisions tend to be easily reversed. Do I call in another worker? I can easily reverse that. I can send them home. Do I send home a worker? I can easily reverse that. I can call them back in, right? In the short run, these are relatively reversible decisions that don't tend to make or break the firm. In the long run, though, everything's variable. So if I had all the time in the world, I could buy another oven if I needed to. If I have all the time in the world, I can relocate my business across town. If I had all the time in the world, I could franchise a bunch of other locations to other people. If I had all the time in the world, I could change from Dr. Plemmmons Cookie Emporium to Dr. Plemmon's Pizza Emporium and just change, right? In the long run, these are time frames in which quantities of all the resources, including the plant size, can be varied. So long run decisions are not easily reversed. If I'm moving my company somewhere completely different, that's not easily reversed. If I change from making cookies to pizza, that's not easily reversed. And then we have this idea of sunk cost, which are costs incurred by the firm that cannot be changed. So if I buy a second oven and I have a second oven installed in my cookie factory, I can't really change that. I've now spent the money on that. I have now sunk the cost of this oven into this oven. I have paid for the labor and the movement of the oven into the store. I paid for the hookup and the electrician and everything else. These are sunk costs. I can't really get them back, right? So if a plant or an item has no resale value, then the entire amount that I pay for it is a sunk cost. Sunk costs are irrelevant to whatever my current decisions are. You know, if I've wasted $50,000 on an oven that I know will only really fit into the one spot that I can put it in, so no one's ever going to buy it from me afterwards, you know what? That's $50,000 I already spent. That's sunk cost. I can't think about it. I got to make my decisions based upon my money generating things and everything else right now, because sunk costs aren't really ones that I can get back. If I can't sell that oven to someone, then I'm out of luck. I need to make my decisions based upon what I can sell and everything else, right? So sunk costs are irrelevant. You might know this with cars, right? Did you ever have a car? I had a terrible car. I've actually had a bunch of terrible cars. Back in high school, I drove this beat up Dodge Neon that I thought was essentially a sports car, and I drove it like a crazy person. But besides that, I had a Dodge Neon, and I broke it all the time because I didn't do things like change my oil like you're supposed to. So in this Dodge Neon, I probably replaced the engine twice. I put in a bunch of new things. I lived in a really bad neighborhood and came outside, and on 2 different occasions my car was on blocks and all the tires were missing, so I put new tires on it. One time they weren't even nice enough to leave it on blocks and the car was just on the ground. We had to get a forklift to partially move it. Anyways, I sunk so much money into this car, but by the time I got to the point I wanted to buy a new car, that car was terrible. No one was going to buy it. It was beat up. It barely run. It broke down every other day. It wasn't even worth parts at that point. All the money that I had put in, the new engines that I had scrapped from the junkyard to put into this car, the tires that I had bought for it, these were all sunk costs, and I wasn't going to get my money back for it. So when I was deciding to buy a new car or not, I had to think about, would the new car bring me value? How much is it compared to how much I'd pay for it? How much I put into this terrible Dodge Neon, of which I probably spent 3 times as much on parts and fixing it myself in my driveway, yelling angrily at it, compared to what it actually cost to buy the car. All that money that I put in, that's sunk cost. And it really shouldn't matter to the decision I'm making on new car or not. I'm sure there's lots of things like that in your life that you've probably put lots of attention and time and money and resources into, but you're never going to get anything back. And sometimes you just have to like cut those off and not have it be part of the decision that you're making for your future and long run goals, right? Same thing for firms, and these are called sunk costs. So let's think about what constraints we have in the short run, right? Because in the short run, in my cookie emporium, I can bake more cookies, I can bake less cookies, I can have more employees, I can have less employees, but I can't change the number of ovens, right? That means that there's some sort of technology constraint in the short run. So to increase output in the short run, I have to increase the amount of labor. I have to get more workers. I have to increase the amount of like ingredients that I buy, right? But I can't necessarily change some of the bigger pieces. There's 3 concepts that describe the relationship in between the output that you're producing and the quantity of labor that you're employing. Because right now, let's just focus on the number of workers that we have. That's a really easy one to predict that I think we kind of know some information about. So let's say that we're trying to figure out the relationship in between how much we're producing relative to how many workers we have on staff that day. We're going to have 3 different ideas. First is going to be total product. How much am I producing in total? The second is going to be marginal product. How much extra am I getting from each person I'm employing? If I bring in a second worker and all of a sudden I'm able to produce 50 more cookies, that's a big difference. The marginal product of that second worker is the extra amount I'm able to produce. It's that 50 cookies. Then we also have the third idea, which is the average product, where I take the total product, the total amount of something I'm making, and I divide it by the number of employees. So let's see what things like that look like. So total product is the total amount produced. Actually, you know what? Let's draw out something, because I think maybe that might be able to make it more salient. Let me pause for a second though, so you don't have to watch me draw. Let's say that this box or bar, whatever you want to call it, this kind of represents the total amount possible that of cookies that I can make with my number of ovens. So with my 1 oven, this might represent the absolute total amount of cookies that I can make. So let's say that we bring in our first worker because we're super excited about our new cookie place. So we're going to bring in our first worker. And when we have our first worker going, this first worker, well, they're kind of busy, right? So they're having to run the back, run the front of house. They're having to talk to employees. They're having to, or well, not employees, but they're having to talk to customers. They're having to roll the dough. So maybe at the end of the day, they can produce, let's say this level right here represents 40 cookies. One day I will be better at drawing. Let's say, let's have level. Actually, no, let's call this total. So our total amount of cookies with 1 employee is 40. That means that the marginal amount of cookies, the extra amount of cookies I get from this 1 worker, are 40. Okay, let's say that I bring in a second worker, right? Okay, well, now that I have a second worker, I have 1 person who can run front of house, and I got another person who can run back of house making the cookies while the other person deals with customers. Wow, they're going to be so much more efficient. Maybe when the 2 of these people start working together, let's say that here, we'll put in all the extra amount of cookies that I can make because we have the second worker. Let's say that maybe together they're able to make 100 cookies. Well, that means that the let's call this one marginal product. So we have total product and marginal product. The marginal product from the second worker is 60 cookies. It's the additional 60 cookies I can make because I hired a second person. Okay, let's hire a third person. All right, I bring in a third person. Maybe like I already have one person in the front of the house. I have one person in the back of the house. They're vibing, like they got their job good. And then I bring in a third worker. Well, maybe the third worker like isn't adding as much value as that second worker did. Maybe that he's not in the same flow, right? So maybe our total amount of cookies is 130. When we have 3 workers working, we make 130 cookies. Okay, well that's our total product. That's the total amount that we have. But with 2 workers, we made 100. With 3 workers, we made 130. So the extra amount of cookies that I make adding in that third worker is 30, right? So these levels, when we add up all of the cookies, those are our total products. When we think about how much the number of cookies increased when we added one more person, that is our marginal product. Now we had one more thing, right? We had average product. And remember, I said that the average product was the total product divided by the number of workers, right? So here, we'll put that in blue up here. Total product divided by number of workers. So let's figure out the average product for each of these. Let's say for this first one. Well, in this first one, we have 1 worker, right? So we have 40 cookies divided by 1 worker. The average product is 40 cookies a worker, right? Totally easy. Okay, let's do the second one. This is our second worker. So in this one, we know that we have 100 cookies divided by the 2 workers who helped to make them. That means that our average product is 50 cookies per worker. If I just do slash worker, that means per worker. Okay, so we see that in the second one, the total amount of cookies we had was 100. The marginal product, so the extra amount that I'm making because of the second worker, is 60, right? But our average product, when I take the total amount of cookies that are being produced and divide it by the number of people there, we make about 50 cookies a worker. All right, let's do one more. So this is our third one. We have 3 workers. When we have 130 cookies divided by 3 workers, this equals 40 math. Oops, where are you? There we go. 130 divided by 3. Fantastic. All right, I wanted to make sure I wasn't going crazy yet. So we have 43.3 cookies a worker. Well, what do we see here? We see that maybe when we first added the second worker, we had some increases in the marginal product. But as we kept adding more people into the store, maybe it starts to have some inefficiencies. Maybe they don't vibe as well. So maybe the marginal product starts to go down. Maybe we don't get as much extra cookies from that third worker as we did from that second worker. When that happens, we see that that's also reflected in average product. Our average product goes up when we have a very productive person that we've put in that has increased the total product by a lot, right? And then it might go back down if we add in more and more workers that might be less efficient each. So these are our 3 different areas. We got our total product, our marginal product, and our average product. Okay, well, let's keep thinking. No, go back. There we go. All right, so we have our product schedules, right? How are we going to produce things? So we know that our total product is the total amount that we're producing within a given period. We know that our marginal product now is the extra amount we're getting from each additional worker. The average product is the total product divided by the number of workers. So we see that we have some technology constraints, right? Because I can throw as many workers as I want into my kitchen. If I still only have 1 oven, they still only have 1 oven, right? So it's not that each of them can produce hundreds of cookies more each. They're still sharing 1 oven. And if I have 3 people or 8 people or 10 people sharing 1 oven, that they're not going to be all that productive. The value I'm going to get from that 10th worker when they're still sharing 1 oven is going to be way less than adding in that second worker. right? So this is what we sometimes see. The more and more, and in this one, notice we have a table. We have our number of workers. This is kind of what I showed, but I wanted to give you a more graphical sense. We had our total product, and this one we're making sweaters. Then we have our marginal product and average product. So we see as we increase the number of people, we increase the total product. The more people we have, the more we can make of something. But the marginal product, the extra bit that I get from those workers, or the extra amount that's made by those workers, will initially go up, and then it's going to go down. If I have a 10th worker trying to make cookies with the same oven that everybody else is using, the marginal product, or the extra bit of cookies I'm getting from that 10th worker, is going to be very small, right? If it exists at all. Then our average product, we see the same thing, might go down. So we initially might go up, and then we might go down, and that's just because it's this total product number divided by the number of laborers. All right, so let's think about product curves. So this is another one that we should probably draw. Here, we'll just move this over here. All right, so we have our example so far where we've thought about our total product, our marginal product, and our average product, but what would that actually look like in a graph, right? So when we graph these, what we do, oh my gosh, that is just not straight at all, is it? Oh well. We're going to have how we're going to label our axis. So notice we normally have price and quantity when we make graphs in here, but now we're talking about output. So we're not going to be talking about price and quantity. Instead, what we're going to be talking about is total output, or total product, whichever one you want to call it, by laborers, the number of workers that we have. Okay, well, let's see in this example. For this first worker, we knew that we were able to make 40 cookies. Okay, with this second worker, we knew that the total amount of cookies that we were able to make was 100 cookies. Then when we added in a third worker, we knew that the amount that we were able to make was 130 cookies. This is what total product curves look like. Now we have two different zones. We have our attainable. This means these are different varieties that we can make, right? So with 3 workers together, they can make 130 cookies, which means, let's say I only need 40 cookies and I have 3 workers. Well, they can totally make that. That's in their wheelhouse. It's attainable to them. It's not efficient. It's not the total amount or the most amount of cookies that they could make, but it's something that they could make. Then we also have another zone. Let's do this in orange. This is unattainable. If I have 1 worker and the max amount that they can make is 40, they cannot make 130 cookies by themselves. We're going to have to add more workers for that. So we have our attainable zone and our unattainable zone. Now let's think about a couple key features here. First, let's think about what our marginal product is. So we know that our marginal product for this first worker was 40 cookies, right? This first worker, we were able to make 40 cookies. That's kind of what their marginal product looked like. When we brought in the second worker, we were able to make 60 more cookies. That's kind of what their marginal product would look like, right? The extra 60 cookies that are coming from there. All right, let's think about our third worker. When we add in our third worker, they were able to make an additional 30 cookies. Why am I giving you boxes that kind of signify what each of these look like? Because I kind of want us to think about the next part. So, let me pause while I erase some stuff. Okay, so when we had just the line of how much we're making for each worker, that was called a total product curve. When we have these boxes that signify how much additional cookies we're getting for each person, this is called a marginal product line. Now, the next one that we need to think about is the marginal product of labor, which is why we have the boxes. So here, I'm going to show you something real cool. Or well, here, maybe, let me first put this up here. Marginal product of labor, or, well, no, let's just go ahead and call it marginal product curve so I don't confuse anyone. Marginal product curve. when we had just the line, that black line, so I'm going to put the title here for what that black line was, we had our total product curve. When we added the boxes, we got the marginal product. Okay, now let's think about what the marginal product of labor looks like. What does that actually mean? Well, let's have one more graph. Like I said, this is a very graph-heavy section, so if you're confused by it, you need to let me know. Let's say that again, we're going to have our number of laborers. And this one we're going to call our marginal product of labor. All right. And in this one, we're going to have the marginal product. So instead of graphing this total output, we're instead going to look at the marginal product. Okay, well, for worker number 1, we know that worker number 1 made 40 cookies. Excuse me. So their marginal product was this 40 cookies that they made. Okay, cool. We have step 1. All right, well, what was the marginal product of worker number 2? Well, that's the extra 60 cookies, right? Because when we went from 1 worker, there were 40 cookies, to 2 workers, there were 100 cookies. 100 divided or minus 40 is 60. So the marginal product of the second worker is our additional 60 cookies. Okay, then finally, let's talk about our third worker. When we bring in the third worker, we went from having 100 cookies to 130 cookies, which means the marginal product of this third worker is 30 cookies. This graph right here is our marginal product of labor. And we show this by having lines that go through the middle part of the top of each of these bars. This line right here that connects these, this is our marginal product of labor line. Isn't that cool? We find this just by taking all of these boxes that we had on the marginal product curve, shift them down, so we squish them down to the x-axis, and then we develop a curve from there. And from this curve, we're able to see our marginal product of labor. Isn't that cool? So we call this curve MP. It's one of the many ones that we need to know. So before the end of today or this lesson, we're going to talk about marginal product and average product, which, by the way, there's probably going to be 3 videos for chapter 11 for you to be able to reference. All right, so we have our marginal product of labor, our marginal product curve, our total product curve. We're down. We got this. So let's go back. With these product curves, we have to show the firm's total product. So this is the exact same thing I just showed you by drawing it out with you step by step, but this is going to be talking about the sweater examples. So let's say that we have this information, from the sweaters that we had in this previous table right here, where we saw how many people we were adding, how that affected the total product, and because of its effect on the total product, how does that affect the marginal and average products? So with this, we have that same sort of line created, right? Because total product curve, that was the same as the black line in the first graph. We see that for this one, in the number of sweaters, when we add 1 person, we're able to make some sweaters. When we add a second person, we're able to make even more sweaters. And a third person, even more sweaters. And a fourth person, even more sweaters. So our total product goes up each time. Remember that we had the 2 regions that I referenced. We had the attainable zone and the unattainable zone. So unattainable means that 1 worker cannot make 15 sweaters on their own. Attainable means that 4 workers, though they can make 15 sweaters, can also make 3 sweaters. If there's only 3 sweaters being ordered, 4 laborers could make that, right? So the marginal product curve was, again, those boxes that represent how much additional sweaters we're getting for each one, right? So in this one, for our first worker, we had 4 sweaters. For our second worker, we had an additional 6 sweaters. So see, we have our box for the 4 sweaters created by the first worker. Draw a line through it. Then when we add in that second worker, well, they went from having 4 sweaters for their total output to 10 sweaters for their total output. So the box for the second worker, this is going to be equal to 6. It's the difference between the 4 that 1 person could make alone and the 10 that they could make together. So 10 minus 4, that's 6. So this is 6. Remember that their average The average product right now would be that 10 divided by 2 workers. So their average product would only be 5, but the marginal product of the second worker is 6, the extra amount of output. Okay, then their third worker, they have an additional 3 sweaters. Their fourth worker, an additional 2 sweaters. Their fifth worker, an additional 1 sweater. Notice that the marginal product gets smaller and smaller the more people that we add. Maybe they're all sharing one sewing machine. If you're all sharing one sewing machine, it doesn't matter how many workers you throw at it, you still only have one sewing machine, right? So that fifth worker might only be able to include or contribute 1 extra sweater. So then we get to our marginal product of labor curve. Remember, we just take all those boxes and we squish them down to the x-axis. In this, we graph our labor versus our marginal product. So instead of having the total output, we're looking at the marginal product. How many extra sweaters we get from 1 more worker. So we see in this one, for that first worker, we get 4 sweaters. For that second worker, well, we went from 4 sweaters to 10 sweaters. Their marginal product is 6 sweaters. So we get this 6 sweater bar, right? Then from 2 to 3, that third worker was able to add 3 sweaters. So they went from 10 to 13. So we see that 3 sweaters is the marginal product of this third one, so on and so forth. So we see our marginal product curve initially goes up. Why does it initially go up? Because sometimes when I'm adding in my first or second worker, it makes things really productive, right? If I have a cookie emporium, that first worker is able to start making cookies, because if there's no workers, no cookies get made. First worker, some cookies get made. Second worker, well, then instead of having one person running around like a chicken with their head cut off, just being like, oh my gosh, I gotta make the cookies. Oh my gosh, I gotta go talk to the customers. If we have 2 workers, I can have someone talk to customers and someone make cookies. Maybe they specialize. Maybe they do really good, right? So marginal product might go up the first couple of workers. But let's say that they're doing well. 1 worker in the front, 1 worker in the back, they're good. Well, if I throw in a third worker, the third worker is not going to be as productive, right? If I throw in a fourth worker, like they're still sharing one oven, they're not going to be as productive. I threw in a fifth worker, it's like, why are you here? We're elbow to elbow, go away. They're not producing as much, right? So marginal product eventually goes back down. So sometimes we might see these spikes at the beginning. Sometimes we do, sometimes they don't, but eventually marginal product goes down. Remember, we call this line MP. So actually, a lot of these slides are just going through what I'm already saying. I'm kind of jumping ahead of myself. Thank you for dealing with my narration skills. So almost all production has these sort of processes where we have the initial jump in marginal returns, and then eventually we have diminishing marginal returns. What does diminishing marginal returns mean? So this is a really important piece of language that you're going to need for your homeworks and your test, because it's really, really important as a concept. Diminishing marginal returns to labor means that the more workers that I put in, the less and less extra I'm getting from each of those workers. That third worker, I'm getting less cookies. That fourth worker, I'm getting less cookies. That fifth worker, I'm getting less cookies as their marginal product. We see it right here in the sweater example. Yeah, marginal product initially went up, but then we have diminishing marginal returns to labor. That third worker is going to not bring me in as many extra sweaters to my total product. That fourth worker isn't going to bring me in as many extra sweaters to my total product. Same for the fifth worker. So they diminish in their additional amount that they're going to produce. Okay, so let's talk about that diminishing returns idea, this law of diminishing returns. Well, when we have increasing marginal returns, that little bit at the beginning, that's because sometimes we specialize or we divide labor, right? So maybe at first, I'm working with someone else, like I can be in the front, they can be in the back. We can figure this out. Maybe we're doing what we're best at. Maybe I'm best at talking to customers while someone else is best at making cookies, which is pretty obvious because I burn cookies every time. But maybe that's what happens. We have our specialization where people do the things that they're best at. We call this a division of labor. But each additional worker has less access to that oven, right? We have one oven and only one place to work. So the more people I put into the business, well, they have less elbow room, right? Like physical elbow room. If the more people that are in there, the less space you have to work. But it also means less time that each of them get with that oven, or less access they get with that oven, because there's still only one, right? So the law of diminishing returns states that as a firm uses more of a variable input, So let's think about variable input. Variable input means something I can change. I can change the number of workers. As I use more and more of a variable input with a given quantity of a fixed input, the oven, the marginal product of the variable eventually diminishes. The more workers I throw in a bakery with one oven, the less helpful each additional baker is going to be. So then remember that we had this idea of our average product, right? How much are they making on average? And that might look a little bit different than this marginal product. So let's again draw this. Okay, so let's think about this. We have our marginal product of labor, which we made earlier in our cookie example. Now let's put in another graph right next to it because I want to kind of compare them side by side. In this one, let's think about our actually, we're going to put in 2 lines in this one. So I'm going to do the first one in blue. And we're going to have this as our average product of labor. So in this first line, or the blue line, which I will label as AP, these are going to be our average product of labor. So we have to vary our labor, right? So our number of workers, and then we have to think about our average product. Okay, so at 1 worker, we know that that 1 worker produced 40 cookies. 40 divided by 1, that was 40. Okay, then for that second worker, we knew that together, for worker 1 and 2, they were able to produce 100 cookies. So 100 divided by our 2 workers, that's actually going to be 50. Okay, then after that, when we put in our third worker, they produced 130 cookies, right? So 130 divided by 4, that was like 40, or divided by 3, that's going to be like 43, right? So what we saw here was that our average product line looks something like this, right? It's just taking those different averages. So what is our total product divided by the number of laborers that we have working? So let's put AP. So that one's going to be for average product. Let's also put our marginal product on the same graph so that we can talk about it. So let's also have this as marginal product. This one's going to be in orange. So what did we see here? So our marginal product of that first worker was 40. Notice that we had put that little black dot in the middle of this bar. So right in the middle, between 0 and 1, we have 40. Okay, then for our second worker, we knew that the extra amount of cookies that second worker makes was 60. So right in between 1 and 2, because it's in the middle of the bar, we see that this is 60. So between 1 and 2 in the middle, we go up to 60. Okay, and then for our third one, we see that the marginal product of this third worker, because we went from 100 cookies to 130 cookies, that's 30 cookies extra, right? So the marginal product of that third worker, they were right in between 2 and 3. This is going to be the 30 cookies that they contribute, right? So what does this curve look like? Well, this curve instead looks like marginal product. So they cross at some point, which may not exactly be here because, you know, I'm just kind of drawing these out. But we have some points where marginal product is greater than our average product. And then we have, which is like right here, right? So at 1, we see that this line is above this line. Our marginal product is above our average product. Then we have some points like over here where average product is greater than marginal product. If we have a vertical transition, let's look in between these. Well, at this point right here, the average product line is above the marginal product line. That's important to just remember that sometimes they switch. So let's think about why that is. Now that we've kind of drawn out this graph a little bit, let's go back. Average product curves look at how many are being produced on average. Right? So how many cookies are being produced on average? How many sweaters are being produced on average? How many, and that's just the total amount that's coming out divided by the number of workers. So in this example, with the sweaters, we had seen that initially average product was below marginal product, much like the cookie example we just saw. So at this point, all the way up until point C, we see that the marginal product is actually higher than the average product. Okay, and then we see here at point C, which is equal to 2 for this example, but it can be different for everyone. After that number of workers, the average product is higher than the marginal product. Okay, so it switches where the average number of cookies made is greater than the number of cookies each additional person's bringing to the table, right? When marginal product exceeds average product, so right here, when the marginal product exceeds average product, the average product is increasing. But notice when average product, this purple line, starts trending downwards. It's right here at this very tippy top, and that very tippy top is where it crosses with the marginal product. Isn't that kind of cool? I think that's kind of cool. So this right here, wherever these two lines cross, we know that that is the maximum of our average product, which makes sense, right? If each additional person after this point brings less and less and less and less and less cookies, then the number of cookies per person goes down, right? So, oh, we're going to cost now. Okay, so with that, we've started to discuss the 3 key components of our product side. So we're going to have a product discussion, and then we're going to have a cost discussion, and then we're going to bring the two together. Bringing them two together is where people tend to get confused. So I would pay attention to this, especially if you struggle with graphs. So what have we covered today? We've covered total product, marginal product, and average product. That's a lot to digest. Go through. Practice making these graphs yourself before you move on. There's going to be 3 videos for this section. One's going to be the product part, one's going to be the cost part, one's going to be putting it together and thinking about the long run perspective. Okay, all right, stretch your legs. I'll see you in the next video.